is Senior Engineering Manager at Toyota, about future tech, zero emission, clean driving, and lots of great stuff. Thank you so much, Jackie, for joining.
Thank you for having me.
It's great to have you here. I have to shout out to Joan Michelson, who is going to be on the show also this week from her Green Connections radio podcast. That's where I first heard you talking about future tech for hydrogen and working at Toyota. And to be honest, I have always been a little bit skeptical of hydrogen in terms of the Mirai, and I was a little bit frustrated. Why isn't Toyota going full steam ahead with the electric battery, like keeping up with Tesla and everything? When I was looking for a new car, I ended up buying a Tesla because I was able to test drive it in Japan. I couldn't do that for the Mirai. I tried to find hydrogen cars to test drive. So I'm so happy that this technology has been a long time coming, but it seems like there's momentum and it's moving forward. So I'm really excited to talk to you about the potential from now, I think.
Yeah, I'm sorry to hear that you weren't able to test drive one. That's pretty surprising in Japan.
Well, I'm not in Tokyo, and I think maybe in Tokyo they have test drive facilities. Infrastructure is maybe there for it's not recharging; it's actually fueling
Refueling.
for
Yep.
hydrogen, right?
Right.
But that was definitely an issue. But you yourself own a Mirai, isn't that
I
right?
do. Yep.
Yeah.
Yeah. I just took delivery of the second generation, which is called the 2021 Mirai.
Yeah, so I saw you presenting about this 2021 version. Tell us about, well, let's start with the latest car and then move back into infrastructure and some of the tech. So tell us about the new car.
Sure. So, to your point, it's a zero emission vehicle, so it's all electric. But instead of being like a battery electric, which you plug in and recharge, you refill it with hydrogen, which takes around 5 minutes or less. And with the newest Mirai, it gets around 402 miles of EPA range estimated on that fill. So it's typically a quicker refueling, longer range, all electric vehicle. And so the second generation Mirai has several improvements from the first generation, not only in that it's very aesthetically pleasing, but it's also lower, longer, and wider than the predecessor. It has lower center of gravity, perfect 50-50 weight distribution, so phenomenal handling. And we've moved to this luxurious platform and put in a rear-wheel drive electric motor, so you get that great drivability for any of those car nuts that is attributed to both an electric motor and a rear-wheel drive vehicle. So really, just a ton of improvements from the first generation to make this vehicle more attractive to the larger audience, and that's exactly what we're seeing here in Los Angeles. There's just a huge demand for this vehicle.
Now, we'll be mostly talking about North America, even though Toyota is a Japanese company. And you were saying the cars are actually made in Japan. But I'd love to touch on your time in Japan, your experience working with the Japanese market a little bit as well. How is it? It must be mostly focused on the North American audience because that's the biggest market in the world. Is that right?
That's actually not exactly
Oh.
true. So the Mirai is a global vehicle, and as you know, since you're in Japan, Mirai actually means future in Japanese. So it is very much it was a Japan developed and Japanese built vehicle. And actually, now I work for Toyota Motor North America, so the North American branch, which is U.S. centric and North American centric. So here we do focus on the North American market, and really it's important that automakers listen to regionally what the customers are asking for, right? What the customer wants here in the US is not going to be the same as what the customer wants in Japan. But what we've done with the Mirai is made this global vehicle, so it's something we can launch in the European markets, the Japanese markets, the North American markets, and make sure that all of our targets for each region are being met in this vehicle. And it's actually pretty easy to do with electric vehicles because they are so superior as far as drivability compared to conventional vehicles. And I think anyone that's ever driven an electric vehicle can attest to that.
Yeah, it's really fun to drive.
It is.
It is not a golf cart.
Yeah.
When I first test drove the Tesla, I was like, Well, I can drop any sports car, muscle car, no problem. So is the 2021, is it like that for drivability? Is it really great pickup?
It does. It has a fantastic pickup. Again, any electric vehicle, right, has that electric motor, which means you get that max torque all across the different range of speeds. So really, you feel that immediate response from the Mirai and the quick pickup.
That's awesome. It's so fun, isn't it? When you've got to pass somebody or you've got to get ahead of the crowd and everybody looks at you like, "Oh, what is that car? That's awesome."
Well, and
And
for me, I always felt this kind of guilt too when I would do it in any other gasoline powered or diesel powered vehicle because I knew there were these emissions associated with me stepping on the accelerator. And now I don't have that guilt. So I kind of might have poor fuel economy because I accelerate more often than I used to, but it is fun, right? And it's not damaging to the environment. So why not go for it?
yeah, absolutely. I feel the same when I go up hills. Usually you would feel bad because of the exhaust, but there is no exhaust, so it's so wonderful. You don't have to feel bad for anybody walking next to it. Now backtrack a little bit for the technology. I love this kids talk that you did, and I think this is such a much easier way to explain it to anybody. So tell us, how does hydrogen power work in a car? Can you tell us?
That is an excellent question. And so many people think that we're still burning it, right? Which is not the case, right? There's no pistons, there's no combustion. All that's happening is that the hydrogen from the tanks is combining with the oxygen from the atmosphere, just from the air, from the intake system. And that hydrogen and oxygen form water that then goes out the tailpipe. And a byproduct of that reaction is electricity that then goes to directly drive the vehicle. So it really is one of the most simple chemical reactions that we're just breaking off that electron and creating electric current and powering the vehicle is really kind of spectacular when you're driving this vehicle to think about what's actually happening to move you forward and how simple it is and that the only byproduct is water.
And to maybe level up a little bit in the technology talk, it looks like there is a compact fuel cell capability happening. So it's easier to apply to other technology. For example, you were talking about trucks. You've mentioned boats, like what is it? The lift. There's a bunch of ways that you can apply this fuel cell system to other types of vehicles or even airplanes maybe in the future. Is that right?
Yeah, so the beauty of fuel cells is that they're extremely scalable. So they can be small enough to power a cell phone, large enough to power a building, or anything in between. And it just comes down to how many more fuel cells do you add into the fuel cell stack to create the power that you need. The energy itself is stored in the hydrogen, which really doesn't suffer from the same struggle with gravimetric energy density, which is just a fancy way of saying weight, as batteries do. So batteries make a lot of sense for passenger vehicles. As you start to get to larger vehicles, heavier payloads, you need more batteries to move that, and that makes it heavier, right? It becomes kind of a self-fulfilling prophecy, but not in necessarily a good way. With hydrogen, you can store all that energy in the hydrogen itself and then make the electricity on demand using the fuel cell. And so that picture that you're showing there is actually just the fuel cell system that's in the second generation Toyota Mirai that's packaged into a box so that people can plug in, the cooling, the hydrogen, and then they can create the power on demand for whatever their needs may be. So two of those systems power our Project Portal trucks, which are our Class 8 hydrogen semi-trucks that are currently operating in the Port of Los Angeles. And you can put even more of those together to power buildings. There's one of these systems on the ship called the Energy Observer, which is sailing around the world right now with zero emissions. So there's all different types of opportunities to use hydrogen and fuel cells to replace specifically diesel generators, these larger machines that typically have historically used diesel.
I went to university just outside LA, like we mentioned off screen before we started. I remember, this is many years ago, there were alerts on the radio that said, don't go out today because of smog levels. So we know that air quality, especially around that LA area, has always kind of been an issue. So it's fabulous to hear about you guys targeting kind of the trucker delivery system, because so much of our goods actually still travel by truck. And what was it, 16,000 diesel vehicles in the LA area alone? So if these can be changed to zero emissions, that has huge positive knock-on health benefits for local residents, right?
16,000 drayage trucks alone that go in and out of the port. And what drayage means is all these diesel semis do, they go into the port, they pick up the containers from the marine vessels from all over the world, and then they drive them up to the rail yards, drop them off at the rail yards, and then the rail yards ship them across the US, right? And the Port of Los Angeles is the largest port in the US. So this is where most of our goods in the United States comes from. So you can imagine the air quality of 16,000 caused by 16,000 of these diesel trucks running that route every day is just astronomical, and it has huge negative implications on the local communities, which are typically the more disenfranchised communities that live around these ports, right? So we actually, in North America, Toyota does not build heavy duty trucks. This isn't a thing that we do, but what we saw, you know, the engineers here in our office in LA, we saw this problem. We knew we had the technology to fix it. So we actually went out and just bought a truck chassis, took apart two systems from our light duty vehicles, put it into the truck, and demonstrated that we could do this. And that's what kind of gathered the support and got the attention of the people who we need to get the attention of to say, wow, this has huge potential. Let's move forward with this. And now we have 5 of these trucks on the road, several hydrogen stations built to support these trucking operations. And we have big goals of eventually moving the entire Port of Los Angeles to zero emissions.
Muted. That's awesome. What is, I know the range, like Luke is saying right now, 402 mile range is great. I got the lowest end Tesla. I can do about 400 kilometers. That's way under. But what can a truck do? What kind of range for hydrogen truck capability is available right now?
So trucks we just put on the road that you're showing here, it looks like, yeah, those are filling. They take about 15 minutes to refill and get about 300 miles on a fill of hydrogen.
That's awesome. So to give everybody a perspective, 300 miles, would that be the coastline from LA to San Francisco? Am I off? How long can
I believe it's about, yeah, it's around like 350, I think, maybe.
Okay.
But it's not, these are not intended to drive up and down the coast. These are intended to drive to replace the drayage operation trucks that just go from the port to the rail yards and back. And, you know, to those truck drivers, time is money. So you don't want them to have to spend half of their day refilling or recharging, right? Because they need to move those goods. They need to get those containers in and out. So we need a range that affords them the current usage cycle that they're used to, which is 300 miles of going back and forth before they have to have a quick refill, and then continuing on their way.
Wonderful. So let's talk about infrastructure, since we're talking about refilling. Now, in one of your talks, you were talking about California had maybe 45 refilling, but in the works, it sounds like you're going for approval of more than 100. Does that look like it's going to happen?
I sure hope so. Infrastructure really is the gating item. And by infrastructure, I don't mean hydrogen infrastructure as a whole, because hydrogen infrastructure already exists. We, you know, as the United States, we make 10 million metric tons of it annually. It's already a commercial commodity. We have hydrogen pipelines. We have hydrogen trucks. We know how to handle and safely distribute hydrogen. What we don't have is the dispensers themselves at the station that get this hydrogen into the vehicle. And that's where we need particular government incentives to get us to have enough stations on the road where we can roll out more and more vehicles to our customers. So we do have a roadmap in California to get to over 100 stations. Ultimately, we'd love to see 1,000 stations, right? So that we can get these vehicles into more and more customer hands, to the people that, want to drive zero emission vehicle, but BEV just doesn't quite fit their lifestyle. People like me who don't have a place to charge their vehicle, right? But I can drive down the road and refill at my local hydrogen station. But we really need to get those dispensers into the ground. And the issue that we're seeing right now is a lack of parity in government investment when it comes to giving money to charging infrastructure versus giving money to hydrogen infrastructure. So for example, in California, I think it was of 200 million, only 40 million went to hydrogen. So, and the rest went to the charging infrastructure. So there's this big gap in education that we need to really help to demystify hydrogen, promote fuel cell technology, and let people see that there is an option for them to drive zero emission vehicle that can fully replace their conventional vehicle when it comes to range and refilling time.
Now, one of the biggest concerns, of course, for hydrogen is you need to use energy to make hydrogen. It's not a power, what is it, low power system. Like you need a lot of energy to make hydrogen as a fuel. There's a trend recently about green hydrogen. Can you talk about that a little bit?
Yeah, and it's as an engineer, anytime someone says, "Oh, it takes energy to make it," well, yes, that's the first law of thermodynamics. It takes energy to make any fuel, right? So it depends on how you make the hydrogen. There are certainly more efficient pathways than others, but the beauty is, hydrogen's attached to pretty much everything, right? So it is a domestic renewable fuel. It's just up to you to find what your domestic renewable source is and make that happen, right? And then once it's in the vehicle, it's incredibly efficient. There is one more energy conversion step compared to battery electric vehicles, which means from a tank to wheels perspective, it will be less efficient. But that doesn't take into consideration how the customer actually uses the car, right? So for me, it doesn't make a big difference to me that my Mirai is less efficient, say, than a Tesla from a well-to-wheel standpoint, because I can't drive a Tesla because I don't have a place to charge it, right? So I don't have a house. So it's totally up to what a customer's lifestyle is and for how they select the vehicle. If people really cared about how efficient vehicles were, everybody would be driving Priuses. And, I wouldn't look out and see a ton of SUVs with one person driving them, right? So it's all about customer preference. It's not about really how efficient the vehicle is. Our goal is just to offer all of these options to the customer and let them choose which vehicle works best for their lifestyle. So that's kind of our opinion on the whole efficiency standpoint when it comes to zero emission and all electric vehicles. As far as green hydrogen,
that's a good point. Yeah, go ahead.
No worries. As far as green hydrogen, what we are seeing now, at least in the US, and I've seen it elsewhere, but I'm not obviously an expert on outside of the US, but there's a huge push to move our grid to renewables, right? And what that means is there's more renewable and distributed electrical generation like solar and wind, which obviously the sun's not shining all the time, the wind isn't blowing all the time. We need energy storage so that when customers are using that electricity, it's available to them, right? And the best way to store that energy is hydrogen, again, because of that really high gravimetric energy density of hydrogen. So we can use that hydrogen that's created from renewables either to create electricity to go back to the grid or directly to fuel our fuel cell vehicles.
Sorry, I muted myself for a second.
No worries.
I just want to make sure I'm unmuted when I'm talking. I sometimes do that. It's green technology, using renewables to make the hydrogen to clean power your car. These are all such important questions and an important part of our infrastructure. But like you said, getting away from fossil fuels, getting away from diesel, having more options, not just one system in place, makes so much sense in terms of really making huge changes along the grid. Now, Toyota has kind of announced they're going to have 20 varieties of zero emission vehicles in the next 5 years or something, as a part of their 2050 targets. Tell us about the 2050 targets. Let's start with that.
I love the 2050 targets. So this was our 2050 environmental challenge. So it's an internal company challenge, but when we set an internal company challenge, we meet it. And so it's divided up into 6 specific categories of ways to reduce our negative impact on the planet. And so the one that you're talking about related to the vehicle fleet is we want to reduce CO2 emissions by 90% in 2050 compared to our 2010 levels. So a mass decarbonization of our vehicle fleet, which means electrification. And again, if we want to really be serious about electrifying our vehicle fleet, then that means we need to electrify so many different makes and models, because our customers don't just want one, right? They want to have a variety of choices. They want, Lexus vehicles and Toyota vehicles and SUVs and sedans and, all different types of models. So we really need to electrify our entire fleet and offer different powertrains, both battery electric and fuel cell electric, for those people that want to charge at home versus those that want to go to a fueling station, right? So that's just one part. The other parts are decarbonization across our entire company. So that means manufacturing facilities, even our headquarters is LEED certified. So we're really trying to look at our facilities and their impact on the environment as well. It includes, improving recyclability, reducing water consumption, and then my favorite is the sixth, which is called harmony with nature. Which means that we just take the extra step to do whatever we can, again, to reduce our negative impact on the planet. And so, for example, here in Los Angeles, our team goes out and we remove invasive species and replant native species here in Los Angeles, and just try to, again, ensure that the company is really going above and beyond to make sure that we're doing our best as stewards of the environment wherever our employees are located.
That's awesome. I also came across a video by Toyota talking about training staff to look for leaks, checking for efficiency as a part of training. Of course, this is a huge part of sustainability in terms of running efficient systems. And we know that training your staff well to understand about energy waste and sustainability is so important if you're going to be an effective business going forward. Can you talk about that a little bit? It's awesome initiative.
Yeah, I mean, so here we say reduce, reuse, recycle, right? But step one is always reduce. And that's not just about the leaks that are in that article, which I do recommend you go have a look at. If you look at your facility, there's so many opportunities to just make small adjustments that really have a huge impact in the long run on the environment. But also, in our office, we did away with things like disposable cups. So everybody has a coffee mug. We have bamboo silverware reusable bamboo silverware. So it's just these small things that you can do to first and foremost reduce any type of loss of efficiency, any type of disposable or one-time use or anything like that. So that is the first step. And this in particular was an example of an initiative in Japan to ensure that there was no leaks in this facility.
Yeah, it's awesome. And such an important part, which is often overlooked. I come across a lot of businesses and they're making a fantastic, very sustainable product. But then you look at how they do operations, you're like, really? Everybody's eating takeout bento from 7-Eleven every day?
Yeah, absolutely. I shudder when I see styrofoam. Like, no styrofoam allowed.
So walking the walk in the office space, in your free time, taking part in environmental activities. Are you doing the tree planting here in this picture, or is it a beach cleanup?
That one, yeah, that was a native species replanting. Yes, yeah, I think we removed or planted 700 trees that day. So yeah, that was a good day.
That's really good. Now, in one of your interviews, you were talking about getting interested in contributing to society in some way when you were looking for career paths. Can you talk about that a little bit? Like your personal journey? How did you end up here?
Yeah, I've always been kind of an environmentally, I guess, now kids call it woke person. I don't know, but I grew up. I was always looking for ways to improve efficiencies around our house. I'd put on, flow reducing water faucets and, replace our light bulbs. And, my parents were always coming home to find something that I did around the house to try to make more efficient. Of course, as soon as recycling was a thing, that became a thing, right? I was like the recycling police, and I still am in my house. I will actually still dig stuff out of the trash if I see anyone has accidentally thrown away something that's recyclable. But it always was so important to me. And, then in high school, when I first got my license, as I think many people do, I fell in love with cars. I fell in love with the automotive industry. I wanted to be a part of it. So I became a mechanic, and then, applied to become an automotive engineer. And one of my first classes in my freshman year of university was on peak oil and air quality. And at the time, we weren't talking about climate change or global warming or whatever you want to call it now, but it wasn't even on our radars yet, right? We were just looking at the immediate impact of the tailpipe of the vehicle on local, human health. And that really shocked me because, in all of my investigating ways to improve the environment, I never really thought of the negative impact vehicles were having. And so that really shifted my focus away from, just building faster, funner cars to building cars that would sustain our environment for the future, right? And not harm humans, not harm wildlife, not harm, Mother Nature. So that really became my shift in focus. And, I can thank university for doing its job there. It's all about education, right?
That's awesome. I think that's so important to have mentors along the way, which takes me to my next question. I would love to ask you to talk a little bit about being one of the only women in the room. You talk about going into meetings. You're still one of the only females in your area specialty. There are a lot of breaking the pink glass ceiling in your industry. So, can you talk about that a little bit?
Yeah, gosh, it's been really fun to be a part of watching the industry grow, even just since I've been a part of it, right? I've been in this industry now for 18 years, and which feels like the blink of an eye to me, honestly. I guess that's what happens when you're having fun. But you just see the women in leadership roles. Mary Barra, I mean, is phenomenal. The ceiling can't get any more broken than that, right? So there are these incredible mentors to look up, and Toyota is particular. We have a phenomenal group of women, and we have this business partnering group called Women Influencing and Impacting Toyota, which brings together women from different divisions where we otherwise are kind of typically siloed, right? Because we're just doing our work, we're in our department, we're not necessarily talking to one another. So we have these special business partnering groups where, based on similar backgrounds, we can all get together and share ideas and share experiences and perspectives. And so through that, I've been able to meet a lot of the other women in leadership throughout Toyota, and share our stories and learn from each other and empower one another. So I think there's something really powerful about that, because then, even though I still am typically the only female in a meeting, there's this huge network of women that's all supporting each other and helping to ensure that there's policies in place that not only attract women to the industry, but then retain them. And I think that that's kind of one of the silver linings of this pandemic, as horrible as it's been, is that it's really shown that we can have a better work-life balance. We can have a hybrid approach. And I think that's going to allow for a lot more women to stay in the workforce when, in reality, they are doing a lot more of the work at home in many instances. But it really affords them more flexibility to both do their job and also to be able to have the family life that's so important to so many of us.
That's awesome. I am a driver. I've been driving since I was 15. And it's something that most Americans do, I think, and most Japanese people do as well.
Mm-hmm.
I married a Brit who has never driven a car in his life. It's like I was so inspired to learn more about hydrogen by watching you and watching you talk about it. To see another woman talking about clean tech, which I'm interested in, even as a driver, being one of the few first adopters of an electric car, right? So I think as a representative of Toyota, you're doing a great service in terms of getting other women interested in this technology. So I really appreciate you being at the forefront. I found this on your Twitter. For anybody who wants these updates, I'm showing a lot of screenshots from your Twitter.
I didn't know anyone
You
actually read my Twitter posts.
Oh my gosh, I'm such a fan. I love your Twitter posts. And you talk about your love of cars even as a teenager, which I
And
also had,
still, yep,
but
still.
not allowed to be in shop. And so you had to teach yourself. Like you pushed through that hurdle, but you shared this great engineers response about women in engineering, and I thought that was great. And then the photo here with you on International Women's Day with another woman who's breaking barriers in her industry. So it's definitely an issue that I think, especially in Japan, especially in America, with these industries, worth talking about, right?
Yeah, that story actually, the post that I shared, this gentleman from another school wrote this letter to all engineering women saying, essentially how much he recognizes and appreciates that they kind of had to go through a little extra to prove themselves in the industry. And at the time when I first entered university, I didn't really recognize that and that struggle in myself. And now as I talk to more and more women, that especially those that dropped their degree, because that was very much a reality at my university as well. The more years that we went in, the more women dropped. And I think it was because it was scary and it was embarrassing, and we did have a larger learning curve, right? I was in my welding class, I had never welded anything, right? And most of the men either did or really were good at faking that they knew how to, but I certainly did not. And I was really embarrassed to try and fail in front of them, right? So I would always try to find like shop after hours to practice on my own or to practice with my professor, because I was embarrassed. I was really concerned in letting my male colleagues see a failure, right? And then feeling like, here's one more example that you don't belong here. So I did feel this need to really prove myself that I don't think I recognized at the time. And then later, as I've had time to reflect on it, I do see that. I do see the struggle that we went through. And when he put that post, there was one line in particular that really stood out to me, to the women, which was who were told they didn't want to get dirty. And that just it was like a light bulb, because that's exactly what happened to me in high school. I really, really wanted to work in auto shop. We didn't have one in my high school, so I enrolled in an auto shop at another high school. It'd be about half an hour drive after I was done with my classes, drive to the auto shop. And this teacher would not let me work on the cars at all. And he would just tell me, no, you don't want to get dirty. Here, go in my office, manage inventory, learn Excel. Positive point, I got really good at Excel, which I still use all the time. So thank you, auto shop teacher. But then he would even ask me to clean the shop after, right? So I didn't learn anything from this man. In retrospect, total misogynist, right? All of the young men that I was in the class with, they would then, we'd go to their house afterwards, and we'd rip apart their cars, and they'd teach me what they learned. And then I'd go home and I'd rip apart my car and learn on my own. But at the time, I don't think I was as angry as I should have been. My dad certainly was. My dad was very angry with this auto shop teacher, but to me, it was just kind of like a reality. It wasn't like this huge inequity. But as soon as I read this, I was like, oh my gosh, how did I not recognize this? What was happening to me at the time? So yeah. And I think, I mean, the more I get out and talk about these stories, the more I hear the same stories back from other women. Like, oh, this similar thing happened to me. But then the sad part is most of them say, so then I dropped the degree and I went to this other, experience. And it's one of, the biggest regrets of my life is, I really wanted to be a PhD in advanced math, and I dropped this math class because of this one incident. And, it's heartbreaking.
Yeah. Well, I'm so glad you didn't give up and you are breaking new ground and inspiring future young girls around the world interested in STEM and going into these tech fields. So, thank you so much. Great job. Uh, let,
Thank you.
let's go back to the tech a little bit. We have some questions. So, going back to what Luke said, he said one of the things he's worried about, which of course is an issue for hydrogen fuel, but it seems like you've gone over the hurdle during R&D of blam problem, a boom factor. Can you just touch on that a little bit? Because
That
I
almost
think
got me
that's
with
a
my water
common,
there.
I think that's a common response, right, for the hydrogen fuel cell.
It is, yeah. And again, I think it's a great opportunity for education. As I mentioned before, when we look at infrastructure, we have safely used hydrogen as a commercial commodity for 50 plus years in the US, right? And you don't hear stories of hydrogen pipelines, bursting, and, you don't hear a lot of boom stories. Actually, if you go back to that photo that from International Women's Day, that woman I'm standing next to, Jennifer Hamilton, is a hydrogen safety expert. And so what we were doing that day was we were at the training facility for the New York Fire Department. And that's part of what we do is we go and we meet with the fire departments. We show them vehicle, we put them on the lifts, we introduce them to the compressed hydrogen storage system. We have them look at all of the safety, mechanisms that are on the vehicle. And most of them, they just go, oh yeah, that makes sense. Looks good. We understand. That's great. So, I mean, if the fire departments are okay with it, which, yeah, it's been really fun educating them all. But that was actually why I was in Japan, was I was working on the compressed hydrogen storage system. And these tanks are incredibly strong and they are engineered specifically for hydrogen. And here's this beautiful thing too about hydrogen being an industrial commodity is that there are codes in place that have been developed over now decades, right, of experience with this fuel that tell us exactly how to handle it, what materials are compatible with it, how to contain that pressure in a safe way, and then what safety mechanisms need to be on board that vehicle. And so, with that code language, actually regulatory language built in, we can ensure the safety of this vehicle. And it's really just like any other fuel. All fuel can be dangerous, right? That's what makes it a fuel. It's an energy carrier, right? So it's all about knowing how to safely manage it. And so one of the beauties of hydrogen actually is how much lighter it is than air, and then it's non-toxic, right? So, my heart breaks whenever I see like an oil spill, because that something that doesn't need to happen. It's something that wouldn't happen with hydrogen, right? It would dissipate out into the atmosphere. So we can actually take advantage of that attribute and to make sure that hydrogen safely dissipates up and away and, isn't contained in some kind of explosive mixture with oxygen. And that's another kind of fallacy is that, since it is at pressure, there's no oxygen in the tank, right? The tank is just hydrogen and it can't explode as pure hydrogen. It needs oxygen in there. So there's a lot of education, and that's part of what we do. But the bottom line is that our number one priority is safety, and we could not launch a vehicle, and we sell this vehicle right to customers. I bought mine. We could not sell a vehicle that we couldn't ensure was at least as safe, if not safer, than a conventional vehicle.
That's awesome. One way you can tell about safety is to think about insurance. So, in getting car insurance for a Mirai, is it very different from any conventional vehicle for the owners?
Nope, I pay about the same. Yeah.
That's awesome. And then we didn't talk about the cost yet. What is the 2021 Mirai going for?
Oh, I'll have to get the exact number for you, but I believe it's around 58,000 now before any incentives. So depending on where you are, there are different incentives, and depending on the base model. So there is two trims right now, the XLE and the Limited. So the Limited is at a higher price point than the XLE, obviously, because it has more, premium features. But I can get you that exact price point. It's at, or you can just go to toyota.com/Mirai and you can see the exact details for yourself.
But this was one of the questions the kids asked as well. Like, why does it cost so much? And of course, it's been, was it 25 years in product development so far? but it's still a very new technology. So it hasn't quite been scaled yet. Making 30,000 new vehicles a year, is that right?
That's what we've scaled up production capacity to handle. So we did have a tenfold increase in our production line. But really, that's gated on where hydrogen dispensers are. What we found is that the success of the Mirai is so closely linked to the experience of refueling the Mirai that we need to ensure there's sufficient dispensers there, or our customers are going to be stuck in lines, or the station could run out of fuel. So there's all of these scenarios that we need to avoid for our customers. So we really need to ensure that the stations are there first, and then we can roll out vehicles. So while we have this production capacity, we can't quite get there yet until we have the infrastructure to support it. And to your exact point, any new technology is going to be more cost intensive, right, than an established technology. And that's attributed to many factors, but one of them being production volume. And so what actually allowed us to launch the first generation Mirai was the development of this device called a boost converter that mated the hydrogen fuel cell system to our traditional hybrid synergy drive system, which is all electric, right? It's electric motor, power control unit, battery, right? And that's all off the shelf. We have millions, I think I heard like 12 million maybe hybrid vehicles on the road now, which actually, when you talk about Toyota not making battery electric vehicles, we actually make more batteries than any, I think actually all of the automakers combined because of our hybrid synergy drive system. So we have all of these electric components, the motors, the PCUs, the batteries already on the shelf in production volumes that we can use in the fuel cell vehicles. And so that's what we need to get to scale with is the tanks and the fuel cell stacks themselves.
Yeah. Yeah, that's true. I mean, the Prius was a huge, groundbreaking new vehicle when it came out as the first hybrid that was really accepted by the general public, not only in the US, but in Japan. Definitely, you see a lot of Priuses on the road. And Toyota is the number one car manufacturer in the world. So it's got a lot of reach, and even small changes have big ripple effects. So it's really nice to see not only hybrid technology, but all electric technology in terms of fuel cell as well as battery, that there is diversity in all the different kinds of models. I think there's a lot of excitement and potential for the whole line. Do you feel that?
Absolutely, yeah, and to your point about the Prius being popular, it actually wasn't when it launched, right? When it launched, people were kind of confused about what it was. Gas was like $1 a gallon in the US, so nobody understood why we were doing it either. And it took about 10 years for the first 1 million Priuses to be sold. And now we sell millions of hybrids a year. So you've really seen kind of, this exponential adoption curve after this real flat, small line of early adopters, and then just this exponential take-up rate of hybrid technologies. And we think that's exactly what the all electric vehicles are going to look like, right? And we're already seeing governments plan for that huge adoption rate of both battery electric, of all electrified vehicles. Really, it comes down to ensuring that the infrastructure is there, because the hybrid vehicles were able to just capitalize on the gasoline infrastructure, which, remember, it took us 100 years to build, right? That's been 100 years in the making now that we're trying to completely reinvent. So it's going to take time, but as we get there, we expect to see customers really start to take off with this technology as well.
Yeah. How many refueling stations are there in California? Did you say over 45 now?
I think we're up to 46. I'll have to check exactly how many we have now. It's hard to tell,
like,
but I think we've opened like 3 in the last month, so I don't want to give you the wrong number.
but we talked about earlier, you're trying to get more than 100 approved in California alone at the moment. So would you say California is like the hub for hydrogen vehicles at the moment compared to other states?
In the US, absolutely. There's actually a greater, it's also a very interesting, I don't want to say experiment, because these are production vehicles that our customers are actually driving, but the fact is that California has a higher demand versus supply for hydrogen versus anywhere else in the world. So Europe and Japan are ahead of us as far as infrastructure. And so they have less vehicles per station compared to California. California has just been a bit behind in the infrastructure because we have such a high demand for these vehicles. But also, to my earlier point, the government investment has been quite not, in parity between battery electric and fuel cell electric. And also, we don't have a national strategy versus, like, for example, Japan, that has a very strong national strategy for hydrogen. So that would really help to, supplement the state's investment to help to put hydrogen stations. So there is a lot of activity now, in the Northwest, some in the Northeast. We're seeing other states that are starting to really start to get invested and try to make their own plans for how their hydrogen roadmap will look. And really, there's a huge amount of momentum right now. So I think this is going to be a really very exciting and hold on tight couple of years for the hydrogen industry, because there's a lot of excitement.
Yeah. I know that they were trying to focus on hydrogen for the Olympics, trying to have a very clean Summer Olympics. But they didn't have, maybe because of Corona delays, they didn't have more than one fueling station in the Tokyo area. So I'm not sure if they've been able to push ahead with those plans. Coronavirus has certainly slowed things down, I would imagine. Is that right?
Yeah, we've certainly delayed some timelines, but overall, I think overall, from our R&D perspective, we've all been able to recover well and keep doing our work from home, and we even still had our essential workers going into the laboratory. So our laboratory never shut down, right? We never stopped building the hydrogen semi trucks. But I think everybody kind of lost some of their schedules. Their schedules got pushed a bit because of the coronavirus. So yeah, and actually, to your point about hydrogen stations in Tokyo, I know for sure there's more than one, because I actually commissioned a few of them. But they do still have the Sora buses operating around Tokyo, which are the hydrogen electric buses that are filling there and operating in the Tokyo metropolitan area. And we are still working towards our woven city concept, which is the hydrogen-based society that's right outside of Mount Fuji. So we're all moving forward with that. And the hydrogen, the Tokyo Flame or the Olympic Flame was lit by hydrogen. So still able to get the wins in there, but certainly there was a shifting of priorities and a bit of delay in certain projects because of coronavirus. But, again, number one goal is safety. We need to make sure first and foremost that all of our team members, and therefore all the communities surrounding our team members, are safe, and that we're not, putting anyone at risk by going into the office or going into the labs.
Yeah. It's definitely an adjustment. Hopefully by next year, a bit more under control in terms of coronavirus, getting back to factories and making things out in the world, not just behind a computer, right?
Yeah,
uh, we
definitely.
we have a question from Frass on YouTube. Thanks, Frass. Can't there be a hybrid of electric and fuel cell to help with the lack of hydrogen dispensaries? So, yeah, go ahead. You tackled that one.
No, I want to know more about which hybrid is he talking. So hybrid just means two powertrains, right? So the fuel cell electric vehicles are hybrids in that, depending on your what part of the driving pattern you're in, you either are taking the electricity from the fuel cell or from a battery. So there is a battery on board the fuel cell electric vehicles. That's mostly to capture regenerative braking or to capture any excess electricity that's being produced from the fuel cell. But it is, vehicles still predominantly driven by the fuel cell electricity itself, just kind of similar to the way a Prius is traditionally driven directly by the gasoline engine. Just take out the gasoline engine, put in a fuel cell. Now we have a fuel cell hybrid. So they are hybridized. I assume, based on the context of your question, you mean like a gasoline fuel cell. And the answer is no. There's just not enough space on the vehicle for both of those powertrains. They're too different. We have, investigated, and other companies have also looked at adding a plug. So that way, you can have a plug-in fuel cell electric. And that way, again, you're not limited to just relying on hydrogen stations. And that is an option, But then again, you need a larger battery, right? If you start to rely more on the battery to provide the motive power instead of the fuel cell, you need a bigger battery. That makes the vehicle heavier, that takes up more space, and therefore you lose more range. So really, it comes down to, what does the customer want? And so far from what we've investigated, we want pure hydrogen to give our customers that long range and that quick refilling time.
I think in terms of Toyota cars, because there is the plug-in hybrid, which is gas battery to recharge the battery. So maybe it is a bit confusing. Like it is battery plus hydrogen for the Mirai, right?
That's right. Yep.
Okay. Yeah. So a little bit confusing. I get it.
Yeah.
But the diversity of types of vehicles. So, for example, Tesla only does all electric cars. It's very simple. But for Toyota, because you have such a diversity of the fleet, it is a little bit more complicated. You probably have these kind of questions all the time, right?
It is, yeah, yeah. And but I think that's one of the things that we've done to position ourselves well, is by having that diversity in our portfolio. And again, being able to quickly respond to what the customer demands are, because we do have expertise in the battery and the electrified component space. Now we also have expertise in the fuel cell space. And, as we're talking about sustainability doesn't just mean something that's good for the environment. It also means that it's resilient, right? And resilient means we have to have diversified fuel sources. We've learned, unfortunately, what happens to our economy and what happens to our transportation sector when we're fully reliant on one fuel source, and suddenly, for some reason, that fuel source is impeded. And so it's really the best bet is to go for zero emission, all electric, but to ensure that we have different ways of getting there, both recharging and refilling with hydrogen.
So one kind of more complicated system, it looks like, is with this boat project, because it would be a battery, solar panels, and the fuel cell tank. Is that right?
Yeah, so I was not personally a part of this project, but I did get to go visit the crew and work with some of our engineers in Europe that worked on this boat. But it's just an incredible engineering feat. Yeah, it's solar panels. They actually have sails that are, I think they act like vertical axis wind turbines almost. Then it uses the seawater, it desalinates the seawater, has an electrolyzer on board that turns that seawater into hydrogen that then uses our fuel cell to create the electricity that powers the vehicle. So, it does make a kind of a combination of all these things. Now, they use hydrogen and fuel cell because, again, if they want to do the same thing with batteries, the boat would just be too heavy. So it's always an engineering trade-off on weight versus how much power density do you need, how much energy density do you need. So how much goes to batteries, how much goes to fuel cell? What's the right mix to make sure that you have a boat that's light enough that it can stay afloat and has enough energy to get you from Los Angeles to Hawaii, like the crew just did.
That's awesome. So seeing this and realizing that this technology is possible gave me hope that there might be airplanes that also use this similar type of technology. Are we going to see zero emission airplanes in the future?
I sure hope so. We're certainly looking into it. There's already a few companies that are spearheading hydrogen airplanes. Most of them are smaller, right? There's been a lot of work around unmanned aircraft, drones, like the lighter, smaller. It is really hard to compete with jet fuel and a turbine, though, right? When you're talking about energy density, man, that is the bee's knees. So it's going to take us a while to get there, but I do think decarbonizing the aviation industry is a huge focus for everyone, including the aviation industry, right? So I'm not sure yet quite what that looks like. I think we already have our hands full, on the ground and in the water for now, but it definitely needs to be a part of our strategy going forward.
Definitely. One exciting thing about that, because it would be zero emissions, one of the problems we're seeing with the melting glaciers is the amount of soot from the airplanes, which is dropping on the glaciers. And because it's not white, it's not reflective of the solar energy coming in, and it melts faster. So that might be something that could really help. Not, there are so many positive knock-on effects for environmental issues on many levels. So I really hope we can focus more on emissions air travel. That would be just amazing to be able to do that.
I think we're starting to really see a push in many different industries towards decarbonization. I mean, we've heard some really great news lately. Speaking with my environmental hat on, not necessarily my Toyota hat, but the shutdown of the Keystone XL pipeline, a lot of these major, oil companies where their investors are pushing them to move towards sustainability and decarbonization. I think that people are really starting to grasp onto it, not just as this kind of, I don't want to say like, kind of like passion project, but they're starting to recognize that this is really essential to the future of humankind and of ensuring that we have that we have sufficient food, that looking here in California at the how climate change has wreaked havoc on our wildfires, right? People are starting to get more directly impacted by these effects that we've been talking about now for decades. And I think because of that, we're seeing real change, not only in the automotive space, but well beyond. And I think you're totally right. People are starting to look at aviation next and say, they're recognizing that it's just not sustainable.
Yeah. So not airplanes yet, but you are working on more utility vehicles. You're focused on hydrogen fuel cell trucks. You also, I love this tweet that you had about donating vehicles to the American Red Cross to help get out vaccines or supplies to the front lines. That was a great story. Do you feel like Toyota is not only focused on environmental issues in terms of clean technology, but also they're a good company in terms of pushing women up into positions of power or thinking about work-life balance? Is it a good company to work for? You feeling that?
I absolutely, yeah. I have drank the Toyota Kool-Aid, as it were. But no, when I joined Toyota, I'd actually worked for several different in several different automotive spaces. I've been in the industry for a while. I've actually been with Toyota just 9 years now. And really, what drew me to Toyota, first and foremost, was that they were cutting edge on the fuel cell technology. So I knew if I wanted to be part of fuel cell technology, that this was the place to be. But also, Toyota is built on these two pillars. One is Kaizen, which is continuous improvement. And that doesn't just mean for the vehicles, that means for the world. And the second is respect for people. And that respect for people pillar is really what I think has carried Toyota through, not only for, there are goals for diversity and inclusion, which have led us to be one of the top rated companies in North America many years in a row now for diversity and inclusion. But also for social equity. We want to ensure that we have a vehicle that, again, isn't just a vehicle for elites or for people that can afford these more luxurious models. We're using our certified used Mirai to make hydrogen and fuel cell electric vehicles more accessible to a much larger portion of the population here in Los Angeles. And this donation to the Red Cross is just one example of many where we have gone out of our way to ensure that there is some environmental justice across the board, not just benefiting those that can afford to be a part of this movement.
Yeah, that's awesome. We just have a couple minutes left, but good question from Brett on the HAPS team. Why do you think Toyota has been so focused on renewable energy sources as compared with other auto brands, even in Japan?
Ooh, that's a great question. Man, I would love to say that I know where that vision came from, but I don't. As Joy already mentioned, the Mirai began development over 25 years ago, which was well before I even knew the technology existed. So I think it comes down to, again, that respect for people and that respect for the environment. And I think someone with a much greater vision than me, maybe it was Akio Toyoda's father or Akio himself, I'm not sure, but somewhere in Toyota there was already this vision, this understanding that what we were doing to the environment wasn't sustainable, and that in order to ensure that people fulfill their maximum potential, they need to be able to move. And if we want to have a sustainable movement for, the future going forward of humanity, then we need to ensure that it doesn't negatively impact the environment. So I do think that, again, those two pillars, that respect for people and that Kaizen, that continuous improvement, has been always what's been driving the company towards the renewable and sustainable goals.
That's awesome. Toyota is, I was teaching business and tourism for many years in the university system in Japan. And Toyota is always an example that I give to students about ethically driven management. And they had a scheme where they had uh, anonymous message boxes in all of the offices, and they really encouraged people to be very honest about their work situation, and so they could improve the system of that the company was running, not only for efficiency but for people to feel better about working there and have better work life balance. And that was happening years ago. So thank you so much for joining today and talking about Toyota, not only about the Mirai, the great technology of the car, but also as a worker there, as a woman, and what you see from the inside. It's been really interesting talk. Thank you so much.
Thank you so much for having me.
Yeah, and thank you everybody for all your wonderful questions today and comments. It was really interesting, and we had some hard ones. Jackie, thank you so much for sticking in there.
The harder the better. I love especially the technical ones. Yeah, happy to answer them anytime.
That's awesome. Thank you so much. And for those of you watching, if you want to join us again tomorrow morning at 9 a.m., we're talking with a poet about his life in Okayama in the Japanese rural countryside and how he's communicating through his art and creativity to people around the world. And then Thursday, 9 a.m., with Joan Michelson of Green Connections Radio podcast about her wonderful stories of empowering women across America, which is so related to Japan and anywhere in the world. So thank you so much, Jackie. Have a great day.
Thank you. You too. And tell Joan I say hi.
I will.
Okay.
Thank you, everyone. Take care. Have a great day.